Hey everyone, and welcome to This Explainer. Today, we're unpacking the absolutely fascinating evolution of version control systems and why they are, quite literally, the ultimate safety net for all your hard work. We're going to trace this wild journey right from the absolute chaos of losing your files all the way to the modern era of seamless, distributed, global collaboration. If you've ever accidentally deleted a crucial file or overwritten hours of meticulous work, well, you are going to find this incredibly validating. Let's get into it. Okay, so let's kick things off by acknowledging a clever, but let's be honest, incredibly error-prone habit that every single one of us has done at some point: manually copying files into time-stamped directories. You know the drill, right? Saving a file as final_v1, then final_v2_real, and so on. The source material points out that this approach is just so common simply because it's incredibly simple to do. But here's the catch: it is dangerously error-prone. When you're relying on manually dragging and copying files into different folders, it's so easy to just forget which directory you're currently in. Before you know it, you accidentally write to the wrong file, or worse, you copy over files you definitely didn't mean to. It is a total recipe for disaster. So, to deal with that exact nightmare, programmers long ago created the Version Control System, or VCS. Think of a VCS as essentially a time machine. It simply records changes to a file or a set of files over time, ensuring you can precisely recall specific versions later on. Now, while our source material often uses software source code as the primary example here, the reality is that you can actually use a VCS to version control nearly any type of file on a computer. And that means this level of control isn't just for software engineers. If you're a graphic or web designer and you want to keep every single version of an image or a layout, which, let's face it, you most certainly want to do, a VCS is an incredibly wise tool to have in your arsenal. It practically gives you a superpower. You can revert selected files back to a previous state, or even roll back your entire project to an earlier version. You can compare changes over time to see exactly how a design evolved. You can see who last modified something that might be causing a bug and pinpoint exactly when they introduced that issue. But best of all, using a VCS generally means that if you completely screw things up or lose files, you can easily recover. And you get all of this incredible security and functionality for very little overhead. Let's look at the timeline to see how this all built up over the years. We're going to trace the three major eras of version control technology, starting from long ago with local VCS, then moving years later into centralized VCS, and finally arriving at the modern era with distributed VCS. What's really absolutely crucial to understand here is the natural progression of the tech. You see, each of these eras was specifically developed to solve a fatal flaw in the system that came right before it. Starting with Era 1, local version control systems, solving the copying chaos. It's really interesting to see how popular early tools like RCS actually functioned. Instead of manually copying whole files over and over again and eating up space, these local systems utilized a simple database that kept all the changes to your files under revision control. RCS worked by keeping what they call patch sets, which are just the specific differences between files in a special format right there on the disk. Then, it could reliably recreate what any file looks like at any specific point in time just by adding up all those patches. At the time, this was a massive leap forward in efficiency for the individual user. But as with all early tech, we eventually hit a wall. While local systems brilliantly protected your own files on your own machine, they completely failed to solve the next major issue people encountered: collaboration. How do we work together? If you needed to work seamlessly with developers on entirely different systems, a localized database sitting solely on your computer just wasn't going to help at all. And that brings us to Era 2, centralized version control systems, the collaboration era. To solve that collaboration problem, systems like CVS, Subversion, and Perforce were developed, and they truly changed the game. They used a single central server that contained all the versioned files, and clients would then just check out files from that central hub. This setup offered huge advantages. Finally, everyone knows, at least to a certain degree, what everyone else in the project is doing. Administrators get fine-grained control over who can do what. And obviously, administering one central server is way easier than managing local databases on every single client machine. For a lot of years, this was the absolute gold standard. However, while centralized VCS gave us incredible visibility, it introduced a terrifying fatal flaw: a single point of failure. Think about it. If that centralized server goes down for just an hour, well, during that hour, nobody can collaborate at all. Nobody can save version changes to anything they're working on. And it gets worse. If the hard disk on that central database becomes corrupted and proper backups haven't been kept, You lose absolutely everything. The entire history of the project is just gone, wiped out, except for whatever single snapshots people happen to have sitting on their local machines. Which leads us directly to Era 3, Distributed Version Control Systems, the ultimate backup. To address that massive vulnerability, that frankly terrifying risk of losing everything because of one bad hard drive, tools like Git, Mercurial, and Darks completely rethought the architecture. I want you to read this quote directly from the source material, because it really is the defining philosophy of modern version control. Every clone is really a full backup of all the data. In a distributed VCS, clients don't just check out the latest snapshot of the files like they did in the old centralized systems. Instead, they fully mirror the repository, including its full comprehensive history. And this architecture, it unlocks the sheer power of distributed systems. Because every single user has a full history mirror right on their machine, that single point of failure is permanently eliminated. If any central server dies, any of the client repositories can simply be copied back up to the server to restore it completely. Your full history is saved on every local machine. Plus, because these systems are literally designed to be distributed, they deal incredibly well with having several remote repositories going simultaneously. This means you can collaborate with different groups of people in entirely different ways all at the same time, within the exact same project. It allows you to set up these complex, hierarchical workflows that were strictly impossible in the older centralized systems. It's a total game changer. So, as we wrap up this explainer, I want you to take a hard look at your own current workflow and ask yourself a serious question. If disaster struck and your central server went down today, right now, do you have a full distributed mirror of your history, or would you lose absolutely everything? Understanding this evolution from simple local copying up to centralized servers and finally to fully distributed mirrors really helps us deeply appreciate the incredible safety nets that modern tools provide us. Don't leave your hard work to chance, folks. Thank you so much for exploring the evolution of version control with me today, and I'll catch you in the next explainer.